Okay, this is section 1.4, which is the basically the first unit that goes over the first type of modeling. So we covered, after we did the some of the financial kind of merchandising type finance type of mathematics, and we did some stuff with scientific notation. And then we were then section 3 we talked about the 4 types of modeling. So that kind of brings us to the first type of modeling, which is linear modeling. Now recall that a model is just a mathematical equation, is all it is. So the equation we're going to use today is y equals mx plus b, and this is standard linear equation where m is slope and b represents the y-intercept. The slope we will talk about in just a second. The y-intercept is the y-coordinate of where the line crosses the y-axis. So some important things about slope. Typically, we refer to it as rise over run or change in y over change in x. In fact, you may have in high school, your high school teacher may have described slope as rise over run, or even change y over change in x. So, you know, how do we understand slope? So really the first thing we're going to do is look at 2 points on a line and determine the slope between those 2 points on the line. And as you can see, this formula here, m equals y2 minus y1 over x2 minus x1 will give us the slope of a line passing through those 2 points. So let's look at a specific example, which is example 1. We're going to find the slope of a line that passes through the points 1, 3, and 3, 2. So let me go to the dot camera and I'll write those points down. They were 1, 3, and 3, 2 were the 2 points on a line. And actually, I might be easier just to do this. So if we do that, what you're going to do, see, your first point will be x1, y1, and then x2, y2. So when we do that, what happens is we plug, this point will be, you know, x1 will be 1, y1 will be 3, x2 will be 3, and y2 will be 2. So when we put those values in, see, 3, 2 minus 3 over 3 minus 1 will give me -1 over 2, or -1/2. So my slope is -1/2 by plugging the numbers in. And I'll keep, the next slide actually has the calculation there. So if you need to write it down, it's there. So again, we want 2 minus 3 over 3 minus 1 gave me -1/2. And if you actually plot the line, recall that the point 1, 3 is just basically, if you go from the origin, it's over 1 up 3. And then from the origin, 3, 2 is over 3 up 2. So if I plot those 2 points and make a straight line, look at the rise over run, or the steepness of the graph. It's going down 1 over 2, down 1 over 2, down 1 over 2. So that -1/2 kind of basically describes the slope of the line in terms of direction, going basically doing your rise and run, or your change in y and change in x. Okay, next example. And I'm going to go back to the PowerPoint. We're going to find the slope of a line that passes through the points 2, 3, and 4, 6. So I will go to the dock camera for a second. And the points again were 2, 3, and 4, 6. So we're going to find the slope, which will be 6 minus 3 over 4 minus 2, which gives me 3 over 2. So plugging in again, subtract y coordinates, so 6 minus 3, subtract y coordinates, 4 minus 2, gives me 3 over 2. So my slope is 3 over 2. And if you look at the picture that I provide with the graph, again, the 0.23 is over 2, up 3 from the origin. 4, 6 is over 4, up 6 from the origin. And if you kind of trace with your pencil between the two red points, literally you're going over 2. Hopefully you can see my pointer, and then up 3. And then here, you're going over 2, up 3. Or even, well, there's multiple points you can do that, but clearly the slope is 3/2. Describing the motion of the line is moving over 2 units and then going up 3 units. Okay, I'm going to leave number 3 as an exercise. So let's do number 4, will be the last slope question we will do. And in this case, we are doing the line that passes between the points 3, 2 and 3, 4. So back to the dot camera. If we compute the slope, we will get 4 minus 2 over 3 minus 3. And that gives me 2 over 0. Now, if you remember from your high school mathematics, we can't divide by 0. This is undefined. In fact, our slope is undefined. So we have an undefined slope here. So what does that look like? Well, look what happens when we plot the 2 points. We get a vertical line. So any vertical line, it doesn't have slope. It's undefined. So that's something that you will use a lot in your mathematics as you go further if you were to take other courses. But anyway, I didn't have the chance to do one, but if you end up with a slope of 0, you have a horizontal line. So a horizontal line has a slope of 0. A vertical line does not have a slope or undefined slope. Okay, so I'm going to go ahead and move on to, recall that the slope-intercept form is y equals mx plus b. I'm not too worried. That's just a review slide. I'm going to look at question 6 now. So going back to the idea of the equation y equals mx plus b, what we're going to do with that equation, as you can see in the question, is we're going to find the slope and y-intercept. So we're staying on the same 3 topics of slope, y-intercept, and equation, the slope-intercept form. But we are given the equation, and what we have to do is find that information, the slope and the y-intercept. So what you want to do is get the equation in this form. Y equals mx plus b. So what I'm going to do is take this equation, using algebra, I'm going to solve it for y. So if you look at your equation, 2x plus 3y equals 6, I'm going to solve for y, so I'm going to subtract 2x. And then I got 3y equals negative 2x plus 6. I'm going to divide by 3. And that gives me y equals negative 2/3 x plus 2. So again, I moved the x term to the other side to isolate y, so it looks like that. And then I have to get rid of any coefficient in front to make it y by itself. So I divide by 3, and I might slide there so you can see it a little better. So what happens is if you look at your main formula, we're in this form, y equals mx plus b. So m is negative 2/3 your slope, b is 2. Now the Latin term for slope begins with m. So that's why they use m. If people, often I get the question, why don't they use s? But they just use the Latin name for slope, and it begins with the m. All right, so that takes care of number 7. And I'm going to leave 8 as an exercise. So now we're going to go backwards. So looking at number 9, so we're going to kind of reverse this process. So in 7, we were given the equation, and from the equation, we found slope and intercept. So it's kind of backwards now. We're going to go from slope and intercept back to the equation. So we're just basically reversing the process we just did. So let's talk about how you do that. So what I'm going to do is go to my main equation, which is y equals mx plus b. And already, if you read the question, I have some of that information. I do have the slope. It's 3. I don't know b, so I have to find b. But I do know the point is 2, 3. So that means y is 3 and 2 is x. So that will be 3 equals 3 times 2 plus b. So what we have to do is find b by, if we plug all the other numbers in, we can solve for b. So we got it down to one variable. So what we can do is just solve this little equation. We would have 3 equals 6 plus b. And if we take away 6 from both sides, we end up getting b is negative 3. And see, now I can go back to the main equation, or slope intercept form, y equals mx plus b. Plug in my slope is negative 3. And actually my slope is positive 3, my bad. And then my intercept is negative 3. So my equation is, I really don't need to plus 3x there. It's probably better to write it as y equals 3x minus 3. Although a positive sign is, I guess, understood if you don't put it there. But if you put it there, I guess there's not a huge issue. But typically in the proper algebra notation, they don't, you want to leave the plus sign off. Okay. Let's go to example 10. And I think I'll go ahead and bring it back up on. Go back to the screen share. Where's the, here it is. Okay, so we're back to the screen share. And we got 3x minus 3. Okay, so we're ready for 10. So find the equation of a line that passes through the points 2, 3, and 4, 5. So again, I'm going to go back to the camera. All right, so how do we do this? This is a little different. The previous example, I was given slope and a point. So what we did was we plugged in the slope, plugged in the point, found b, and then we were basically done. This is a little bit different because I don't know the slope. But if you recall, if I have 2 points, I can just find the slope by using the slope formula. So that's what I'll do. I'll go, so my slope would be 4 minus 3 over 4 minus 2, and that yields 2 over 2, which is 1. So my slope is 1. So now it's sort of like the problem that I had previously, because now I have the slope and a point. I actually have 2 points, but that actually doesn't matter. In fact, we could use either one of these points. So I'm going to use the first point. So if you go back to the main equation, plug in 1 for slope, 2 for x, 3 for y. I get 3 equals 2 plus b. So if I find the intercept, it's 1. My slope is 1. So my equation is y equals x plus 1 or 1x plus 1. And again, you guys feel free to email me if you have any questions. Okay. 11 is a similar type problem. The solutions there, you can kind of, you can work that one on your own and check it. This video is getting a little bit long, so I'm going to try to get this last example in number 12, and that'll wrap it up. So it says the revenue of a company that makes backpacks is given by the formula R equals 21.5, where X represents the number of backpacks sold. And what we're going to do is graph this model or equation that basically finds the revenue for selling backpacks. And then then after we graph the model, we're going to use the model to calculate the revenue for selling 50 backpacks. And then we're going to talk about the meaning of the slope. So one of the things about sketching a graph, one of the better approaches is just to make up a chart and then, plug in, select, 4 or 5 values for X and plug those in and see what happens. So what I did was I just tried 10 backpacks, as you can see in my chart, 20, 30 backpacks, and 40. So that's my X value. And then my Y values will be here. So what happens is if we put 10 in the formula, 21.5 times 10 is $215. If I plug 20 into the formula, 21.5 times 20 is $430. If I plug in $30 times my 21.5, it's $635. And then last, if I plug in 40, I get $860. So what I'm going to do is take this information and make a graph. I think the one I have in there it's okay, but I think I can do a better one by hand. So let me do that right now. So what I'm going to do is sketch graph, and hopefully the little box you see on the side is large enough just to kind of see what I'm doing. But I'm actually only going to sketch positive X and Y axis. And then what I'm going to do is plot those points on there. So I'm going to do, it appears that I went by tens with X. And I got to figure out a good range for the top. So why don't we go, because you range up to almost $860. Let's just label by hundreds. And I might put a mark in between to represent 50s. So let's see if we can get this all squeezed in. There we go, all the way up to 800. And actually I'll go all the way up to 900 because you're almost at 900 by the time you do 860. So all right, so what I'm going to do is, I guess I will go to the dock camera for just a second when I plot these. So your points were, and I'm going to have to at least bring this up, maybe minimize it so I can see the plot. Okay, so looking at your PowerPoint, we're going to plot 10 and 215 will be about right here. Just go a little bit above 200. And then you're going to go 20 and 430. Again, you kind of have to estimate just a little bit right about there. Just, you know, a little bit in between 450 and 400, probably a little bit closer to 450. And then we're going to do 30 and 635. And then you can do 40 and then 860s up here. So if I connect my points, actually going to pass through the origin. It looks like that. Oh. Let me see if I can kind of fix that a little bit. That's not very good. Here, I'm going to go ahead. I'm going to redo that real quickly. That came out much worse than I thought it would. Hopefully I can resketch it real quick, just better. Okay, so that was a quick makeshift of changing, and I'll mark in 50s in between, like I did. All right, so let me see if I can make this look a little better. So 10 and 215, 20 and 430, 30 and it was 635 if you look at the charts. Be right there on estimating, and then 40, and then about 860 be roughly about here. So let me connect. Okay, yeah, that's much better. My point's a little messy. I'll clean that up. Now I'll label the values I had on the graph. 10, 215, 20, 430, 40, or excuse me, 30, and 635. And then that might have been, I think that should be 45. Pretty sure. I'll double check that. And then 40 and then 860. I believe that value is wrong. I have to do a quick check on my calculator. Yeah, it should be 645. So let me go. I'm going to go. Let me kind of take away. I'm going to go back to the PowerPoint. Here we go. And I'll change that to 45. And then you can kind of see the graph on the side. So hopefully that will work good enough for you. Sorry about the technical difficulties, but I think we got that fixed. Okay, so the next question asks, use the model to calculate the revenue for selling 50 backpacks. Well, once you already have the formula, all you have to do is plug in 50. So if you plug in 50 into the equation, you'll see that you'll get 1,075. And then the last question is, what is the meaning of the slope? The slope represents the price per backpack. So as you can see, because remember my slope is 21.5. So that basically you're comparing cost or revenue, actually is the term, the best term. And then here you're talking about units. So it's backpacks. So it's revenue per backpack, which is $21 revenue per backpack. Okay. Or it can be price per backpack, either one, because it is the rate that you're charging too. Okay, so at that kind of, we're getting a little bit long in time here. So I'm going to stop the lesson here. There is one more example you can do if you want to work it and then check the answer. So the next unit will be on math quadratic modeling. And until then, just work on these questions or email me if you have any questions.